I love me some linear models, and who doesn't want to play with trend lines? Let's do it. Let's compare. So here we have two graphs. They show the same thing. Average global temperatures from the years, 1970 to 2021. I just want to point out the difference. It's the x-axis. In the top graph, it says years since 1970, and it starts at 0. That means x is 0 when the year is 1970. So in 1980, x would be 10. Okay, so that's the top one. In the bottom one, it's just year. So when we have 1970, that means x is 1970. If we were talking about 1980, then x would be 1980. Notice, y-axis is the same, graph looks the same. The big difference then is in the equations. Okay, and we're going to look at those here in just a moment. First, we need to interpret the slope. The slope is the same, 0.01737 for both of them. It's positive. So the numerator, remember, we're talking y's over x's when we talk about slope. So what do the y's represent? Well, degrees Celsius. What do the x's represent? Years since 1970. Okay, now take that and put it into a sentence. So the temperature increases because it's positive, 0.01737 degrees Celsius every year after 1970. I like to write out my slope like the y. What does the y represent? What does the x represent? And then put it into a sentence. It's so much easier when I can just pull the numbers out and put them into a sentence. Try to make your life as easy as you can. What does x represent in each of the graphs? Well, we've already talked about this. X is the years since 1970, and it's the same in both, right? It's just the way they are described in both. Use the trendline equation from this graph given. This is the top one to predict the average global temperature for 2020, rounded to the nearest tenth. Okay, so remember in this one said in 1970, x is 0. So if we're talking about 2020, how many years after 1970 is 2020? Well, that's 50 years. And if you don't know, just subtract. If you subtract them, that'll tell you how many years. So we have x is 50. So we are going to substitute 50 into the equation. So I've got my 0.1737x plus 13.92332. So I substitute my 50 in. 0.01737 times 50 plus 13.92332. Order of operation tells me to multiply first. So I get y equals 0.8685 plus 13.92332. Final step, add those together, and I end up with 14.79182, blah, 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 rounded to the nearest tenth, 14.8 degrees Celsius. Okay, which is great. That's right here. Okay, 14.8. I love this for us. Remember that. Now let's go to the second graph. Remember, the second graph shows the same thing, but we have a different equation. And so now if we're looking at 2020, now we're going to use x is 2020 because look at the x values. If you ever wonder, do I use 0? Check out the graph. If you are using what's given in the graph, that's an easy way to look. So again, we write our equation, 0.01737x minus 20.28805. X is 2020, so let's substitute that in. 0.1737 times 2020 minus 20.28805. We multiply because order of operations is a thing. So 35.0874 minus 20.28805. We do our subtraction and we get 14.79935, which is roughly 14.8 degrees Celsius. Point being, this is a big struggle for a lot of students of, do I use the years? Do I use the 0? Honestly, it doesn't matter. It really depends on how you see it and how you like it. Some people really like their X values to be smaller. So they want to use, okay, if I'm starting in 1970, then that's 0. It makes it easier from a y-intercept perspective because, you know, the y-intercept is when x equals 0. So that's easier in this case to say, okay, when x is 0, my y-intercept is 13.92332. That means in 1970, that was the y-axis, right? That was the degrees Celsius. Whereas, changing topics, when you're using the average global temperature, this here is not the y-intercept because 1970 is not 0. 0 in this case is the year 0, like over 2,000 years ago now. So over 2,000 years ago, the average global temperature in this equation would have been negative 20.22805 degrees Celsius. That doesn't make any sense, right? So that's where the whole, do I use zeros, do I use years, where does that come? It's all really based on how you see it and how you like it. But mathematically, it works out the same.